Welcome to Math with Professor V. Here is your latest integral of the day. We have indefinite integral of 8 dx over 4x squared plus 1 quantity squared. So pause the video if you want to try it on your own. I'm going to jump into my solution, and the first thing I went for was a trig sub because I was looking, I didn't see x to the first in the numerator, so u sub wasn't appealing. And then just be careful because there's a coefficient, right, on x squared here. So normally when we do trig sub, you just let x equal, in this case it would be a tan theta, but now I need to go ahead and let 2x equal 1 tan theta. Okay, so you have your variable quantity squared plus the constant squared, and you let x equal a tan theta. But in this case, since it's 4x squared, you want to think of that as like 2x quantity squared plus 1 squared. Make sense? Oh, good. Okay, so then from here, we can differentiate both sides. So 2 dx equals secant squared theta d theta. And if you want, let's just get rid of that 2. So dx is 1/2 secant squared theta d theta. All right, so now let's go back to the original problem, rewrite it all in terms of theta. So we've got 8 times, instead of dx, I'm going to write 1/2 secant squared theta d theta over, now 4x squared is, that's right, tangent theta squared. So I'll just write tan squared theta plus 1. And all of that gets squared. Good? Beautiful. Okay, 8 times 1/2, that's 4. Let's put that outside the integral, so it doesn't stress us out any more than it needs to. And then we've got secant squared theta d theta up top. And then remember, anytime you do trig sub, it's so you can use a Pythagorean identity. So I'm going to replace tan squared theta plus 1. You got it, with secant squared theta. And then all of that is squared again. Ooh, so this is 4 times the integral of secant squared theta d theta over secant to the 4th theta, since I have secant squared squared. Squared squared makes 4. Okay, secant squared from the numerator cancels. Then I'm just going to have secant squared in the denominator. But secant squared in the denominator is the same thing as having cosine squared theta in the numerator, right? Beautiful. Do we know how to anti-differentiate cosine squared theta? Yes, you just become a little math robot and you go, I'm going to use my half angle identity. So 4 times, you're going to replace cosine squared theta with 1/2 times 1 plus cosine 2 theta d theta. That's the only identity to use when you're working in an integral. I know there's other identities for cosine squared theta. It's 1 minus sine squared theta, but that's not going to help you evaluate the antiderivative, okay? And then let's just go ahead. We can proceed from here. Let me just take 4 and 1/2, group them together. That's 2. And then antiderivative of 1 is just theta. Antiderivative of cosine 2 theta, because of the 2, I need to put a 1/2 in the front. And then this is sine 2 theta plus c. Good? Okay. Now, before you get too excited, it's not time to box the answer. Let's distribute the 2, and then we have to go back to the original variable of the problem, which was x. Exactly. And in order to do so, we need to draw a triangle. So remember, we had made that substitution. We let 2x equal tangent theta. Think of it like 2x over 1. So tangent of theta is the ratio of the opposite over adjacent side. So there's theta, opposite side is 2x, adjacent side is 1, and then this is going to be square root 4x squared plus 1. Now notice, this is a triangle for the angle theta. However, I have a 2 theta here. That's going to be problematic. Not really. We have a double angle identity, so I'm going to replace sine 2 theta accordingly. That way this triangle will be of use to me. So this is 2 theta plus, I'm going to replace sine 2 theta with 2 sine theta cosine theta plus c. Now it's triangle time, okay? Now, When you have theta all by itself like this, you go back to the substitution that you made and you use that inverse trig function. So what do I mean? I mean, I can say theta is equal to tan inverse of 2x over 1, or just 2x. So that's what I'm going to substitute in for theta. So I've got 2 times tan inverse of 2x, like that, plus, let me scoot. Then we have 2 times sine theta is the ratio of the opposite side over the hypotenuse. So that would be 2x over square root 4x squared plus 1 times cosine theta. Well, cosine theta is the ratio of the adjacent side over the hypotenuse. So that would be 1 over square root 4x squared plus 1 plus c. Good? Okay, and then it's almost cleaned up. Notice I have the same radical quantity in the denominator, so the square roots are just going to go away, and then I could put 4x up top. This is simplified as can be. Don't do anything weird with this 2 and the 2x, okay? I hope you weren't thinking such nasty little math thoughts. 2, I don't like how I wrote that. Sometimes when you forget your algebra rules, you start inventing new weird ones, so just be careful. 4x over 4x squared plus 1 plus c. Come on. There we go. Okay. So that concludes the integral of the day. Did you get it right? Did you do it differently? I'm curious if someone did it differently without a trig sub. Some people are trig sub haters, but trig sub's so versatile and efficient. I think it can be intimidating if your trigonometry is not strong, in which case you can check out the video lectures playlist, trigonometry, on my YouTube channel. Anyways, thank you guys for your support. Don't forget to get the video thumbs up, subscribe if you haven't already, and then follow me on Instagram, TikTok, Math with Professor V. I have plenty more videos on trig sub, so if you're just learning it for the first time in Calc 2, have no fear. I'll help you become professional at it, and I'll be back sooner than later. Bye!